Something impossible is hiding in plain sight. A single desert could power the entire planet, and no one is doing it. That's not science fiction. That's real. And the strangest part? It would only take a tiny fraction of one place, the Sahara Desert. But here's the question no one asks. If the solution is this simple, why hasn't it already happened? Because the truth is deeper and way more complicated. Right now, the world is running out of fossil fuels. Demand is rising. Climate pressure is building. And we're searching for something, anything, that can replace it all. Solar energy looks like the answer. Clean, endless, powerful. But there's a problem. Solar farms take space. A lot of it. And they only work where sunlight is constant. So where on earth do we find a place that gets sunlight every single day and has almost no competing land use? The Sahara, a massive, empty ocean of sand. Endless sunlight. Untouched land. It almost feels too perfect. But that's where things start to get strange. Because scientists have already done the math. And the number they found changes everything. If we covered just 1.2% of the Sahara Desert with solar panels, we could generate enough electricity to power the entire world. Not part of it. Not most of it. All of it. So now the question flips. If we can power the world with a tiny slice of one desert, what happens if we actually try? At first, it sounds like the ultimate solution. Clean energy. Infinite supply. A global reset. But here's the strange part. Covering the Sahara wouldn't just change energy, it would change the desert itself. And that's where things get weird. Because deserts aren't just empty spaces. They're delicate systems. Right now, the Sahara reflects a huge amount of sunlight back into space. Its sand is pale, bright, almost mirror-like. That reflection helps regulate Earth's temperature. But replace that bright sand with dark solar panels, and everything flips. Instead of reflecting sunlight, the ground starts absorbing it. Temperatures rise. And when the ground heats up, the air above it heats up too. Hot air rises. And rising air pulls moisture into the atmosphere. Then something unexpected happens. Rain. Not a little rain. A lot more than before. Enough to completely disrupt one of the driest places on Earth. Vegetation starts to grow. Grass. Shrubs. Even trees. The Sahara begins to turn green. Let that sink in. A place known for endless sandstorms could slowly transform into a living ecosystem. But that's not even the craziest part. Because once plants take hold, they trap moisture, which leads to more rain, which leads to more plants. A feedback loop. A chain reaction. A desert rewriting itself. So now the question gets even bigger. What happens when we don't just change the energy of the planet, but the climate itself? At this point, it sounds like a miracle. Clean energy. A greener Sahara. A cooler planet. So why aren't we already building it? Because here's where reality hits. Hard. Producing energy is only half the equation. The real challenge is moving it. Electricity has to travel. Across countries. Across continents. Across oceans. And that's where things start to fall apart. Most of the power from the Sahara would need to go somewhere nearby, first, like Europe. But to get there, we'd need massive transmission lines stretching thousands of kilometers. And long-distance power comes with a cost. Energy loss. Up to 10% disappears during transmission. That's not small. That's billions of dollars gone. But here's the strange part. Even if we solve that, a bigger problem is waiting. Infrastructure. Many regions around the Sahara don't have stable electrical grids. Some areas struggle to deliver consistent power locally, let alone export it globally. So now we're not just building solar panels. We're rebuilding entire energy systems. Across multiple countries. At the same time. And this is where it gets even more complicated. Because energy isn't just science. It's politics. And politics changes everything. So the question shifts again. Even if we can build it, can the world actually agree to run it? This is where the dream starts to crack. Because the Sahara doesn't belong to one country. It stretches across more than 10 nations. Each with its own government. Its own priorities. Its own risks. And not all of them are stable. Now imagine trying to coordinate a project worth trillions of dollars across borders that shift, policies that change, and leadership that doesn't always last. Investors see that and hesitate because one political shift could shut the entire system down. And that's not a small risk. That's everything. But here's the twist no one expects. Even if every country agreed, even if the money was there, even if the technology worked perfectly, we might still hesitate. Because changing the Sahara's climate isn't just a side effect. It's a global experiment, and we don't fully understand the consequences. More rain in the desert sounds good, but what happens to global weather patterns? What happens to winds? To oceans? To ecosystems thousands of miles away? Because Earth isn't a collection of separate systems. It's one connected machine. Change one part, and everything responds. And that's when the idea flips completely. What if solving one problem creates 10 new ones? Now the question isn't, can we do it? It's, should we? So we're left with something unsettling. A solution that could power the world, but might reshape it in ways we don't fully understand. A desert that could become green, but at an unknown cost. And a project so massive, it depends on the cooperation of an entire planet. But here's the strange part. We might not need to go that big. Not yet. Because there's another path. Smaller, slower, safer. Instead of covering the entire Sahara, we start with pieces. Local solar farms, powering villages, cities, regions, building stability first, infrastructure next, growing the system over time, and maybe, just maybe, learning from each step before scaling up. Because sometimes the biggest ideas aren't meant to happen all at once. They're meant to evolve. But that leaves us with one final question. If we already have the power to change the world, why are we still waiting? And more importantly, when we finally decide to act, will we be ready for what comes next? Or will we discover that the cost of infinite energy is something we never expected?